Very good morning, dear students. I hope all of you are doing good and safe. So, in today's session, we'll be learning about the third component of the vapor compression refrigeration system, namely the expansion devices. So, you know that in a refrigeration system, there are two pressure levels, high pressure level and low pressure. In the high pressure side, you have the condenser where the heat rejection is taking place and the refrigerant changes its phase from vapor to liquid, and in the low pressure side you have the evaporator in which the phase change happens from the liquid to vapor by absorbing heat. So let us understand the basic functions of an expansion device as well as the various types and their working. So in any refrigeration system, an expansion device is used to reduce the pressure of the refrigerant from condenser pressure, high pressure, to the lower pressure, the evaporator pressure. So sometimes this pressure drop is also accompanied along with the temperature drop. Always it may not be so, depending on the pressure and temperature values. So that case is specifically important in the cryogenic applications that we will learn with the help of another important term known as Joule-Thomson coefficient in another session. So that is the first function of the expansion device, to reduce the pressure. The second function is to regulate the flow. A metered quantity, only a specified quantity depending on the requirement in the evaporator needs to be supplied. So that also is taken care by the expansion device used. Now there are two major types of expansion devices: variable restriction type and constant restriction type. In most of our household refrigerators, we can see the constant restriction type, that is capillary tube, which is a narrow long tube. On the other hand, under the variable restriction type, you have automatic expansion valve, thermostatic expansion valve, and float valves. The automatic expansion valve functions based on the pressure sensed from the evaporator. Thermostatic expansion valve is working based on the temperature at the outlet of the temperature of the refrigerant at the outlet of the evaporator. And float valves is merely simply a working depending on the level of refrigerant in a chamber known as float chamber. The working of the float valve is similar to the float valves used in a water tank. Now coming to the detailed specification, the working of different types of valves, let us begin with the automatic expansion valve. So as I said earlier, this type of valve works in response to the pressure changes in the evaporator. So the quantity of the refrigerant to the evaporator is controlled with respect to the pressure changes in the evaporator. So the essential components are a needle valve, a seat to place the needle valve, a diaphragm, and a spring. So there are two pressures acting on either side of the diaphragm, the spring tension in the spring as well as the pressure force in the evaporator. So these two forces or pressures regulate the movement of the valve. So let us see the construction. So you have a spring. The tension in the spring is adjusted or preset using this adjusting screw, of which the pressure is PS. This PS is the spring pressure, and you have the diaphragm here. Okay, one end of the valve is connected here, and this is the valve and the seat, valve seat here, needle valve and valve seat, and this is the exit to the evaporator, and this is the entry from the condenser. Okay, so the refrigerant will be flowing in this way from here to here. Okay, PE is the evaporator pressure. Let us suppose the evaporator pressure is set to some 2 bar. Okay, so evaporator pressure is set to 2 bar. Now, if the pressure is above 2 bar, what will happen? Suppose the pressure of the refrigerant in the evaporator is above 2 bar. Always the evaporator should work at a lower pressure, right? If the set pressure and the evaporator exceeds the set value, the pressure exceeds the set value, what will happen? This PE will be more than PS. Okay, so under normal conditions, this will be in equilibrium. PS will be equal to PE, so that the valve will be at a position so that the regulated flow will be happening. So if PE exceeds, this valve will be moving up by the action of this pressure at the bottom side of the diaphragm. So it will be moving up against the spring force. So valve will get closed, no refrigerant will be flowing to the evaporator. Now, in the other scenario, if PE is less than PS or PE is less than set pressure in the evaporator, less than 2 bar, what will happen? So, obviously, PS will be higher than PE. So, this will come down, more refrigerant will be flowing to the evaporator through the valve. So, that much simple is the working. So, just simply based on the pressure sensed from the evaporator, the valve is getting operated. Now coming to the second category, thermostatic expansion valve. It ensures that refrigerant flow in the evaporator matches the evaporation rate. That is, there is a thermostat or a feeler bulb, specifically called as feeler bulb, which is connected to the evaporator outlet or compressor inlet. The temperature of the refrigerant at the evaporator outlet will be sensed by the feeler bulb here. Okay, and that will control the flow. So here you can see the inlet again at the bottom and the outlet is here to the evaporator. So there are two forces or two pressures. One pressure is the feeler bulb pressure P1 and P2 the evaporator pressure, P3 is the spring pressure. Okay, so there are three pressures or forces acting, one downwards and two upwards. So depending on the relative values of these three, the temperature, so obviously the temperature sensed by the feeler bulb will be converted to some force here, and again the evaporator pressure will be acting here, and the spring pressure, preset pressure of the spring will be acting through this rod. So depending on the relative values of these three, the amount of refrigerant flowing through the valve from the condenser to the evaporator will be regulated. Now coming to the third type of valve under variable restriction type, that is float valve. It is normally used with flooded evaporators, which we are going to learn in the next session, the types of evaporators. So flooded evaporators, we have to use float valve. So the important function of the float valve is maintaining a constant liquid level in a chamber known as float chamber. So there are two types of float valves. Low side float valve usually connected to the evaporator side, and the high side float valve usually connected to the condenser side. So this is the working. So from the condenser, this is a high side float chamber. Okay, this is a high side float valve. So valve is placed after the float chamber. So depending on the rise or fall of this float, this valve will be operated. So these are the differences. In a high side float valve, the needle and seat of the high side float valve are at the outlet of the chamber, as we have seen in the previous slide. But in the case of low side float valve, the valve will be placed before the chamber. So if the liquid level in the chamber rises, that is, the float will rise, the valve will operate. On the other hand, on a low side float valve, the valve is placed before the float chamber, when the liquid level falls, the valve will operate. The second category of expansion device is a constant restriction type. Under that, we have seen the capillary tube. It is a long narrow tube. It may not be placed as a long tube, but it will be wound to um, um, so like I mean to place like a spring kind of arrangement on a rod, or simply wound like a spring and placed. So the restriction is to the flow is obtained by the pressure drop because of the friction offered by the walls of this narrow tube. The dimension typically will be of maximum of 0.5 to 3 millimeters of diameter, and the length is of the order of 1 to 6 meters. So when the refrigerant flows through such narrow tubes, it has to overcome the friction offered by the walls. So that friction will cause a pressure drop. That is the working principle of a capillary tube. So these are the different types of expansion devices used in refrigeration systems. If you have any doubts, any clarifications, please feel free to contact. So we will meet with another interesting session on evaporators. Till then, goodbye. Thank you for watching.